सृष्टि से पहले सत नहीं था, असत भी नहीं, आकाश भी नहीं था, अंतरिक्ष भी नहीं, छिपा था क्या, कहाँ, किसने ढका था, उस पल तो अगम मतल जल भी कहा था. Well, this is how an ancient Indian text describes the nothingness from which the earth or the universe came into existence. Well, we don't know anything about this nothingness, but we have enough reasons to believe that the universe came into existence with something called as the Big Bang. Now, about 13.6 billion years ago, something like an egg broke and all the chemicals were let loose. They were all spilled around. But to know exactly what happened when this Big Bang actually took place, let us imagine that last bell of your school after which the school is over, that chutti wali ghanti. So what happens when that last bell rings? The bell rings and all the students, they just flutter out into the ground. All the students all at once. But once they are out into the field, have you noticed that there are clusters, there are groups? And these groups are formed based on the closeness, the friendships, the fact that they belong to the same class. So basically, they are based on affinities. So, something similar must have happened when the Big Bang took place. There was a big blast, all the chemicals were spilled all around, but once they were spilled all around, they formed clusters. Clusters or clouds that were based on affinities. Affinities of reacting with each other, affinities of charges, forces of attraction, forces of repulsion with something else. So there were factors that brought things together and formed small clusters or small clouds. And these clusters or these clouds, perhaps they evolved into what we see today as the galaxies. And our galaxy, the Milky Way, also had one such small cluster, and we know that the cluster was called as the solar nebula. Now, this solar nebula, solar because there was a center, a reacting center, a light emitting and energy emitting center, and clouds all around. Clouds that were made up of dust, that were made up of charged gases, that were made up of particles reacting, moving randomly and at a very high energy. And all the energy came from that center, that reacting center which was called the solar center. And the cloud of charged gases, particles, ionized particles, some neutral particles, this cloud was called as the nebula. As the central reacting center started cooling down slowly, the gases and charged particles all around in the nebula, they also started getting settled. They started getting condensed. And as they started getting condensed, the solar nebula, as we say, it developed into the solar system. The system was formed by condensation of various particles of the cloud to form the 8 planets that we know today to be the part of the solar system. So what are these 8 planets? We know that there are 8 planets in the solar system, and we belong to the third planet, the Earth. And what are the other 7 planets? What are the total 8 planets of the solar system? Just after the Sun, there is Mercury, followed by Venus, Earth, and Mars. Then comes the immensely sized planet Jupiter, followed by Saturn, followed by Uranus and Neptune. I hope you all know by now that Pluto used to be a planet, but it has been demoted from the status of planet very recently actually. Now, if you look at all these 8 planets of the solar system, there is something interesting that you must have already noticed. If you look at this picture, the first four planets of the solar system, the Mercury, Venus, Earth, and the Mars, they are all smaller in size. And the rest four, Jupiter, Saturn, Uranus, and Neptune, they are immense, they are larger in size. There is another thing that marks the two groups of planets very remarkably. Mercury, Venus, Earth, and Mars, all four of them, they are together called as the terrestrial planets because they have a rocky surface and they have less or no moons surrounding them or orbiting them. As compared to that, Jupiter, Saturn, Uranus, and Neptune, all four of them are either gaseous or they have an icy surface. And all four of them are either surrounded by very prominent or lesser prominent rings around them. They are all immense in size and they have multiple moons orbiting them all the time. So, the Sun is surrounded by four terrestrial planets, which are the four planets which are closer to the Sun, and four planets which are called the Jovian or the larger planets. Jovian because Jove is another name for Jupiter, the Roman god, and because all the four planets follow Jupiter, they are called as the Jovian planets. So the terrestrial planets and the Jovian planets are the two groups of planets which are a part of the solar system. So we live on the third planet of the solar system. This third planet, the Earth, the blue planet, is the place where life chose to evolve. Perhaps because of the presence of water, because of the chemicals, the minerals that are present on the surface of Earth that sustain life. Now, if we look all around us, it is probably a little difficult to imagine that we are living on the surface that is curved or ball-like. It is like an ant crawling over a huge basketball or a football, not being able to understand whether the surface is flat or curved. Now, the reason we cannot feel the curve, is the reason why for a long period of time, Earth was imagined to be like a tabletop. A tabletop that was present, supported by certain aquatic animals with water bodies all around. The sky was like a canvas, the canvas that was supported by hills and mountains. And this canvas was dotted with stars, small lights like the stars and all the other celestial objects. Now, a beautiful imagination, no doubt, but this was also a very popular imagination. This imagination was even published in form of flatbed maps of the earth. These maps were even used for short-term explorations and navigations. People were not very comfortable navigating or exploring longer distances at that time, but for shorter distances, these were the maps that were in circulation. It was in the year 570 BCE that this gentleman, Pythagoras, a polymath, he for the first time suggested that perhaps Earth is a sphere, a circular sort of structure, and he would say that because he observed that every celestial object moved in one direction. He saw the sun rising from one direction and setting in the other. Again, the next day it would rise from the same direction and set in the other. All the other sky movements, the sky line, would always move in one direction and come back from the same direction the next day. So he said that it was smart to imagine that the earth would be a sphere and everything was circling this sphere. This smart observation or this smart idea was even supported by Aristotle, who also believed that earth was perhaps a spherical structure. These, however, were hypotheses. They were not supported by concrete evidences. And some amount of evidence came with Galileo Galilei, who invented a telescope. Now, there were two evidences, circumstantial evidences given by Galileo. The first thing that he observed was that when you look through a telescope and when you're observing a ship moving away from you on the surface of the ocean, across the horizon you would see that the object seems to be setting down. Now, had the earth been a flat surface, you can imagine that this will never occur. This can only occur if the earth was actually a curved surface, like the curved surface of a sphere. This happened to be the first observation made by Galileo to suggest that the earth was perhaps a circle or a spherical structure. The second very important observation that Galileo made was that when he observed through the telescope, he saw that all the other celestial bodies are spheres. Moon was a sphere. Some of the planets that he could observe were spheres. So if everything else was spherical, it was again smart for the earth. It was smart to imagine that the earth would also be a sphere like all the other celestial objects that were present around it. Again, the idea was circumstantial, not actually proven. It was actually proven by two very brave explorations. The explorations are called circumnavigation explorations. Circumnavigations meaning a person deciding to navigate around the earth, around the circumference of the earth. The first ever circumference or circumnavigation exploration was taken up by this gentleman, Ferdinand Magellan, and he was a Portuguese explorer. This Portuguese explorer, for the first time, tried to go around the earth to prove that if you start from one point, you can come back to the same point, proving that there would be a circle or there would be a sphere. Similar explorations were taken up by another very famous gentleman, Christopher Columbus. He was an Italian explorer and he also took up such circumnavigation kind of explorations, and in fact a lot of new continents and lot of new islands are dedicated to him for his discovery. Apart from these two physical explorations where it was proven that Earth was actually spherical, some proof of Earth being sphere or a spherical structure also came from observation of the lunar eclipse. If you observe the lunar eclipse, if you see the photograph here, you can see the shadow of the Earth is visible on the moon. And this shadow clearly appears to be an arc. And since it appears to be an arc, it was clear that perhaps the Earth was also a sphere. Final and the most evident kind of proof to tell us that the Earth was sphere came from the satellite images of Earth. A beautiful satellite image that was sent by the first ever satellite that went into space, and such kind of photographs finally proved that Earth is a beautiful blue spherical structure. So, the Earth is actually a sphere. This idea was first proposed by, say, Pythagoras, supported by Aristotle, but then the actual proof of the Earth being a sphere came from observing objects going down the horizon, observing other celestial bodies which were also spherical, circumnavigation explorations, observing lunar eclipse and the shadow of Earth on the moon, and finally through the satellite pictures of Earth. Now, through all these events that we have covered so far, we have actually not talked about one very important gentleman and one very intelligent piece of story. This story belongs to this very innovative gentleman, Eratosthenes of 250 BCE. Now, he was the head or the chief librarian of the Library of Alexandria, which is in Egypt. And his theory was based on a very intelligent experiment, and a very small piece of observation. Now, Alexandria is a city in Egypt. There is another city in Egypt, the name of that city is Syene. Eratosthenes knew that on 21st of June every year, there is a no shadow time in Syene, which means that at 12 o'clock in Syene on 21st of June, the objects do not cast any shadows. Now, today we know that this is a very common kind of observation, but for Eratosthenes in the year 250 BCE, it was something very intelligent. Now, with this small observation in mind, he designed an experiment. The experiment goes something like this.
So Eratosthenes on 21st of June did something very ingenious. He imagined that if he planted a stick in Syene on 21st of June, as observed, there will be no shadow. And provided that Earth was a flat surface like it was popular during 250 BC, if he planted another stick in Alexandria, the two sticks will actually be parallel to each other, and therefore the stick in Alexandria should also have no shadow on it. However, what he observed was very amazing. Eratosthenes observed that the stick in Alexandria actually had a shadow, and the shadow subtended at an angle of 7.2 degrees at the top of the stick. Now, consider that the rays of the sun are falling parallel on the surface of the earth. If they are falling parallel on the surface of the earth, they are parallel in sign, and so they have to be parallelly falling on surface of Alexandria as well. And if Syene does not cast any shadow, then Alexandria should also not, if the two sticks were lying on the flat surface as it was popular during that time. However, if there was a shadow at an angle of 7.2 degree, it meant that the two sticks were not meeting the parallel rays of the sun equally, and it was possible only if the two sticks were not present on the flat surface of the ground but were present on a curved surface, something like this. If they were on a curved surface, something like this, the rays of the sun falling parallel or falling straight overhead on sign would not cast a shadow here, but the same parallel line, if you see here, would cast a shadow because they are now at an angle in Alexandria. This observation was taken further by Eratosthenes. He thought that, or he hypothesized that, the earth might be a sphere. And if it had been a sphere, he calculated the circumference of the earth with this setup. How? A very interesting and intelligent experiment. Now, with a stick in sign, he knew that the sun's rays are falling on it directly, casting no shadow, and these lines would ultimately meet the center of the earth, which he imagined to be a circle. This line in Alexandria, the line itself, would actually also meet up to the center because it will be like a radius. However, the rays of the sun are parallelly falling on it, so it will fall like this. Now, he had already calculated that the angle of this parallel line of the sun and the stick was 7.2 degrees. And if this line is parallel to this line, these two angles will be alternate, and therefore this angle should also be 7.2 degree like it is observed here. These are alternate angles formed at opposite sides of a diagonal of a parallelogram. So by theory, these two angles will be equal. They will both be 7.2. So, the distance between Alexandria and Syene, which was approximately 800 kilometers, 800 kilometers on the surface of the earth was equal to 7.2 degree in terms of the circle. So a circle is actually all of 360 degrees. So by simple calculation, what he did was that if 7.2 degree is equal to 800 kilometers on earth, then 1 degree would be equal to 800 divided by 7.2, and therefore 360 degree, which would be the entire circumference of the earth, would be 800 divided by 7.2 multiplied by 360. And interestingly, the answer that he found was very accurate.
His answer was 40,000 kilometers, while the actual circumference of the Earth is astonishingly very close to this answer. It is 40,075 kilometers, so very close to the actual answer is what Eratosthenes calculated. Now, Eratosthenes, his experiment is very important in the stages of history, not just because it stated or it hypothesized the spherical nature of the earth, but also because it indirectly calculated the circumference of the earth to a lot of accuracy. It is noteworthy at this juncture that Indian astronomy and what we called the Indian astrology at that time was also very developed, especially during the Gupta dynasty, which was around 300 to around 470 CE. During this period, Aryabhatta also calculated the speed of rotation of the earth around its own axis as well as its revolution around the sun, and it is said that the speeds that were calculated by Aryabhatta were also of a lot of accuracy. Now, Earth is one of the planets of the solar system. It's a spherical body, and today we know that there are seven other planets together with Earth being a part of the solar system. It is very interesting to note that Earth is the only official name of a planet that is not derived from the name of any Greek or Roman god. Earth just means the land or the ground in English. So, this further proves the fact that we realized the existence of Earth as a planet a lot later as compared to the other planets which we had already named as per our Greek and Roman gods and goddesses. With that, we come to the end of this particular lecture. In the coming lectures, we will further talk about the surface of the Earth and the distribution of various characteristics of Earth. But till then, see you next time. Thank you.